Okay, it's done actually. Yep. So these are the things that we need to cover. Okay, for the previous section. So coming to daemon, okay. Daemon is like it's a background service that manages Docker containers on system. Got it? Like its responsibilities like building, running, and managing containers. So the daemon is like a, we can call like a API, okay, the one who mediate the Docker to our machine. Got it? So first, when we hitting like Docker build or Docker run, first is communicate with the daemon, okay, and yep, it's Docker API request and manage images, containers, networks, and storage. Then daemons, it's like a critical component that makes it's possible to interact with the Docker. Okay, all thing is high level. Okay, got it. Anyone have any doubt regarding Docker daemon? So, for example, this is the daemon. Okay, my screen is visible, right?
Yes.
Yeah,
Yes,
yes.
yes, it's visible.
Okay. So daemon act as a API. It will deliver all things in background. We didn't bother about the thing. So, for example, like how can we explain the things? Yep. Think the Docker daemon as a backstage crew at a theater. Okay, like setting up the stage, managing all things and coordinate actors, all things. I mean, in the backstage, right? So while the audience, okay, interact with the final performance, that is called container. So they don't worry about the technical details. Got it? So it's like a mediator. API calls, and here the daemon is daemon. My paint window is visible.
Yes.
Okay. First, we communicate with the daemon actually. Got it. So this is like as a API code. For example, here our requirement is to run to build a image. Okay. So here we will put the thing like docker build or any command first we given to the terminal, right? Docker on anything. So when you hit enter, first it will communicate with the daemon. Got it? Any doubt? And we didn't bother about this part because this is entirely a background process. This is a background process. Okay. Background process that manage what? Manage what? Manage nothing.
Docker commands.
No. Containers. On a system. Or here. And the rest of the thing. What is the rest of the thing? Build, run, etc. Fine. Any doubt? Okay. I think we are going with the CMD. This is one of the instruction. Okay, so we learned some other instructions in Docker file, right? Docker file. What are the instructions we already covered? Anyone? From. This is the first one we learned in previous section. Second instruction is run, right? Third, expose. Copy. These are the Docker instructions we.
Even the entry point and command.
Yeah, CMD and entry point we will cover. Okay. So coming to the CMD. CMD 6 entry point. And as per the requirement, there is so many other instructions there that we need to customize as per our project requirement. Got it?
I see we use maintainer label, but those are just for
Sorry.
We also use the maintainer label, all those things. Those are
Maintainer and yes, that's all up to the requirement. Okay, for example, some scenario like actually labels and maintenance we are keeping in a Docker file for mentioning the user profile actually. Okay, for example, actually maintainer is deprecated. The label is there. Okay, so some Docker files, both are included. Yep, label is a Docker key value pair that can be attached to images, containers, and other Docker objects. So it's provide it's provide a metadata about this object and can be used for categorization of these images. Okay, not categorization. We can identify and some other case like we can some management purpose. Okay, to keep these types of images, so we can uh, using the label. Okay, it's labels means it's like a tagging or like that. You can sort out that thing fastly. You got. So the thing is we can easily identify the uh, image because uh, we have a two different Docker. Okay, I mean Docker image. So that two one is for two purposes, and they have their own versions and some other things like other attributes or anything like that for each image. Okay, that two image. So using labels, we can get more information about each one. That's all. That's why we are keeping the labels inside our Docker file. Make sense or confused? And nowadays, we didn't mention for a single Docker file that labels. Uh, we are using tag file in building the image. Okay, using Docker image, we can add tag. And coming to maintainer, it's another instructions in Docker file that we used for specify the image and contact details of the person. Okay, that who is responsible for maintaining that Docker file. Got it? For example, yep. For example, how can we tell that? Yep. In a real world scenario, okay, we take a real world scenario. Like in a art gallery, okay, consider an art gallery. There might be a so many pictures there, right? Writing pictures, painting, and in each painting there is a artist name and the contact information, right? Got it? So that paint or that artwork maintainer of the painting ensure its preservation and what and the authenticity of the of the person, right? So same in our Docker file. So who are the owner or which author or which engineer done the Docker file? I mean the full Docker content and the image, all things inside the Docker file. That's why we're keeping maintenance inside the Docker file. So when we open the Docker file, we can see that is belongs to this user or that user. Got it? Any doubt?
Yeah, thank you. Yeah.
Now you got the idea, right? For the maintainer and label.
Yes.
Okay. So the main part is CMD and the entry point, because these two things happen when attending the interview. Okay, I mean the interviewer asks regarding CMD and the entry point. So yes, coming to CMD, okay. CMD is a Docker instruction, right? Say Docker instruction. A Docker instruction in our Docker file. Docker file. Specify or specifies the default command that will be executed when you execute that when a what container start. Okay, so when a container is start, okay, I mean yep, we run the container. Okay, after we build the Docker file, then we run the container. When the container is start, yep.
There's a message here concerning your laptop charger that is going down. Can you check if you're okay before it goes off?
Thank you. I plug it down. Yeah. So Docker instruction, not Docker instruction. Leave. CMD instruction in Docker file with the default command that will executed when a container start. Okay. Got it. And coming to entry point. Entry point instruction in Docker file. Defines the execute trouble that should be run when the container starts. You got the first point, comparison with the CMD, because when we creating a Docker file, at the end, we put the instruction CMD or entry point. Some other cases we can include both, okay? So most probably we are ending with the instruction entry point or CMD as per our requirement. For example, when we include CMD instruction in our Docker file, the CMD instruction in Docker file specify the default command that will executable when a container starts. After the CMD or entry point, we mention the thing, okay? Like, for example, our application, our Docker file belongs to a Java application, okay? So that Java application, there is a var or rar dot Java, right? Then that's the package to start the Java application. So when the container runs, okay, at the same time, we need to start the Java application, right? Inside the container. So that purpose, we need to include that thing in CMD or entry point. So the CMD will, inside the CMD instruction, we mentioned that when the container starts, we need to start our Java application. So all thing we mentioned in the CMD and entry point. Any doubt for the first point?
Hello.
Yep.
Can you re-explain the intro point for me a little bit again, please?
Yes. Yeah, I will explain more regarding entry point. Okay, first I will add one more thing in CMD. This is the default command. Okay, we include in the CMD. And coming to entry point, we will add the primary command. Okay, like here the thing is overridden in CMD, and coming to entry point is not overridden. So like used to define in the main process that runs inside the container. Okay. So this is in CMD we use to define the main process that run inside the container. The main process is, in our case, I will explain that the Java, okay, for the case of Java, we need to run the java.var. That's the main process when starting the container. Got it?
Yes.
And coming to CMD, here are the arguments. Actually, these are the arguments, okay? Inside this, we need to add our arguments like ABC. This is example, okay? Comma, BCA. These are the arguments we specify inside the CMD or entry point, okay? For example, here we need to put one dot. This is for a Java application, okay? So Java. Okay. And here also, here we can add, these are the examples, okay? Amp dot. This is for some other example with the Python, like that. And entry point is nothing, it's similar like CMD, okay? Don't bother about that. I mean, no confusion or anything. It's similar like CMD, but here arguments passing or passed to the container. Container, and it will, will be like, it will be treated as to the entry point. Got it? So I will explain one real world scenario so you will get more idea about that thing. Coming to CMD, okay. Imagine we are in a restaurant kitchen, okay? A restaurant kitchen, okay? So coming to restaurant kitchen, okay? There is a chef, right? Inside the restaurant kitchen, there is a chef. Chef, okay. And we can call that chef as what? As when comparing to CMD, we can call as chef as a default command, okay? Default command. This is a default command, okay, in CMD. So in our real world scenario, inside a restaurant, there is a chef. We call that chef as a default command. So the default command jobs are what? Like might be to prepare the daily special, right? Prepare the daily special. Okay. So when we enter the restaurant, start the container like that. Okay. When we enter the restaurant, start the container. The special is automatically being prepared, right? For example, when we entering our restaurant, it's like the container is started off with the CMD. So the special is automatically being prepared, right? Because we didn't mention to the chef or the waiter, please make the special or like that, right? Because it's special for the restaurant. So it will be included in our what dish. That's called in CMD, the default command is there because that's the one is default for CMD. Prepare the daily special. Yes. Any doubt?
No, it's okay by here. So, this is the CMD. Like you compare like a restaurant. So, what about the entry point? What you can compare to?
Yes, I will compare to the entry point. When coming to entry point, we can take another example like real world. Think of we are we are in a self service, okay, self service car wash, okay, like a car wash, and it's self service, okay, it's self service, okay. We are in a car wash place and it's a self service and yeah, the entry point here, entry point is like is control panel with buttons. Yes, and instruction. For us, right? Or for the user. So no matter who use the car wash, car wash, no matter you use the car wash, the steps are same and not and any additional input like additional form or anything. It will be modifying the same process. Got the idea? When coming to a car wash, okay, this is an example for the entry point. When coming, this is a real world. When coming to a car wash, there the entry point is a control panel with the buttons and instructions for the user. Okay, no matter who use the car wash, the steps are same, and any additional input like additional foam or any other material to wash the car, it will be modify the same process. Okay. For example, another example in real world, like for example, in entry point, we include some other commands. Okay, we when we are running the container, okay, I mean running the images, we include some more commands. Okay, inside we like docker run, then our -t, -t and -port dashboard. Then the port number, the image name, this the our application container's name. After that, we need to include some things, okay, in the same parameter. So that will fetch with the entry point and execute the thing. I think you will get you will know some issues, right? I mean confused.
Yeah, it's okay.
Sorry.
It's okay. It's okay. Thank you.
So you got the idea, right?
Yes. Yes.
So entry point we mostly use in advanced scenarios. Got it. And for us, normal case, we can use simple application like Python or Java, anything, we can use CMD. So coming to entry point, it will use in advanced scenarios, some use cases, advanced use cases. Some like such as treating command line arguments as argument to the entry point commands. Command line argument means in terminal, right? In terminal, we need to add some arguments when running a container. Got it?
Yes, sir.
Any other doubt?
Oh, it's okay. We can continue.
Okay. If anyone have any other doubt, then we can go to the Kubernetes section because we missed one lab. Everything is fine. What about others?
Kubernetes.
Again, good to go with the Kubernetes, right? When coming to each section, okay, I mean, first we deploy our application in EC2, right? You remember, first we set up the EC2. This is our EC2, okay, EC2. Our requirement is deploy application, right? Deploy application. So again, we are go with the what? Container. Our requirement is same, right? Deploy application. And now we are go with the Kubernetes. And what is our requirement? Same. Deploy application. So as a DevOps engineer, our requirement is to set up all things, all infrastructure for deploy a better application infrastructure. Got it? Okay. So previous section, we go with the high level of Kubernetes architecture and the components, right? So Here we are choosing the entire resources, entire, for deploying the application. Coming to container, there is a EC2, right? And the top of the container engine, we deploy the application small size container. Okay, we deploy multiple application. And coming to Kubernetes, we choose our machine, resource machine. And for our case, we can add 2 node. Okay, here coming to Kubernetes, here our machines, I mean the same EC2 is called as node, right? Node 1 and node 2. Node 1 and node 2 is a replication. Okay, we keep 2 nodes because, for example, if any node is down, our resources are in this node. That's why we're keeping 2. Same scenario in traditional way, we set up a application. We configure 2 bare server. Okay. Same in here, EC2, we configure for the load balancer. You remember that we set up the same machine and balancing, load balancing to the each one. This is a traditional one. Traditional one also we keep 2 machines for high level application for high availability. Okay, for high availability, because each one, for example, anyone is down, our application is there, so there is no interrupt for the users because users can access our application. And yeah, that's the scenario. That's why we're keeping at least 2 for each scenario. Each scenario means in container or coming to cloud, on-premise, in Kubernetes also. So we need to set up the Kubernetes cluster. Okay, so there is multiple way we can set up our cluster. One is command line. It's the easiest way to deploy a cluster. The another way is go to the AWS console. I think Suman is new join here, right? You there?
Yes, today only.
Okay. So you are familiar with the cloud technologies or fresher?
Yes, yes, I know.
No, then I think you will get the previous recording. Go through that. Okay. If you have any doubt, ping me.
Yeah, where can I get this
Yeah, I will share.
to check with the HR?
Yeah. As of now, I think we are covered 9 or 10 sections.
Okay.
We are now entering to the DevOps tools like EKS, Docker, and all things.
Mm-hmm. Okay,
So,
I'll check with the
yeah. Okay. Fine. So this is the another way. Okay, to go to the console, and here we can. This is EKS. Okay, this is the Kubernetes offered by Amazon. Okay, I mean AWS. So they will provide the entire Kubernetes service as EKS. This is their name, EKS, Elastic Kubernetes Services. But this is Kubernetes actually. So we can easily go through this, like create cluster, go to the cluster, we can see there is no cluster here, create cluster, and go through the step-by-step process. It's a user interface mode. And another way to interact with this Kubernetes cluster is command line. Okay. For example, we have a remote machine. Assume that we have a remote machine and we authenticate with our cloud provider, I mean this AWS account, and with a single command we can set up our cluster with our desired node. Okay, so these are the 2 ways first we will go with the easiest way. Okay, this is also easiest, but as a developer engineer, we didn't go here and do the things. We all do with the command line. Okay, anyone have any doubt? So for that purpose, I need one remote machine. Okay, for my machine, I couldn't authenticate with my AWS account. So I need a machine. Consider this machine as a remote machine or my own machine. Yep, remote machine. Remote machine. And this is the cluster. Okay, this is not cluster. This is the AWS account. So I need from here. This is my PC. From here to AWS, there is a service EKS. Okay. So my requirement is to set up the EKS. So I need to first I need to authenticate with this machine. Then when coming to EKS setup, there is one command line tool. Okay, that tool name is EKSCTL. Got it. So I need to ensure that I installed EKCTL in my local machine. EKCTL. EKCTL is managing the Elastic Kubernetes service. Okay. For example, we need to delete or we need to create a Elastic Kubernetes service. We need to install the EKSCTL. This is our Amazon EKS command line tool to interact or to manage our AWS EKS service. And after that, we need to manage our Kubernetes, right? I mean, now we are going to the core Kubernetes. So to manage Kubernetes, we need to have one more tool. Anyone know which tool we are using for managing Kubernetes services? Anyone? Command line tool to manage or interact with our Kubernetes cluster.
kubectl.
Right. So these are the prerequisites installed in our local machine. EKCTL and kubectl. For example, we are going to the same in Azure. Okay, Azure there is another name, not EKS. Azure is AKS. Okay. Azure name is AKS. So we didn't install EKCTL or anything, just install kubectl and Azure login also. That's for the Azure provider. Now we are in AWS. Okay. So verify that we install these both. So yep. Quickly, I will show you how to install the thing. Before that, I need a local machine, right? So I don't have a local machine. So consider I am choosing one machine from the EC2. Go to install one machine. This machine is for interacting with my EK service. A base machine just for the interaction. That's all. I successfully connect to my local machine. Consider this is my local machine, okay?
Voici comment nettoyer ta boîte.
Sorry.
No, sorry. It's okay.
Okay. So this is my local machine. So what are the prerequisites I need to talk with the EKS? That is EKCTL and kubectl, right? So first I am going with the yum update. Thing there. So I need to download the EKCTL from this directory. Okay. Copy. This is a package where the EKCTL. And go back here. And now it's done. I need to move to the entire thing to where user local bin.
So can you please put the command in the chat window?
Yes, I will.
Third command. Thank you.
The version EKCTL version is 0.5. It's done. Now I need to install Kubernetes. I mean not Kubernetes, kubectl. All thing I done in my local machine. Okay. Now I need some permission to read write for the kubectl. Check the version. So the kubectl also installed with the version v1.2.2.6. Now both are done. Okay, kubectl. I mean the prerequisites are done. So I need to add one role for, because in my scenario, this is considered this as a local machine, but this is not a local machine, right? Now scenario, I am using a AWS machine, right? AEC2. So this is the EC2 I am using, and this is a service I need to configure. This is my EC2 machine, EC2, and this is the service I need to configure EKS. So these two are different services by AWS, right? For this case, I need to create a role. That's role called service role, because these two are the services. Okay. So these services needs to talk with these services. That's a requirement. So you need to create a role for this purpose. Okay, to authenticate these two services and attach the role. First we need to create the role, and we need to attach the role to the one who we need to perform. Okay, here the performer is EC2 machine. So EC2 machine will manage or will create the things. So we need to attach the role to the EC2 machine. For managing and handling EK services, there is a role in that's provided by IAM role. So go to the IAM. And go to the roles. Here left side users role, so many things there. Okay. And here we need to, I think I have the role. We type EKS. Service role for EKS. First, I need to check the role. Okay.
Excuse me, sir. These features will be available for the free Amazon account also, right?
Sorry.
Are these features available for the
Yes.
free tier Amazon account also, right?
Yes. Yes, I think this is the role delete. I have the role. Okay. This is the role. Okay, I will create one role. Okay. Go to create role, type EKS. So this is the role actually, AWS service role for Amazon EKS. Okay. So go back. Again, type EKS. First go to the role and create role. This is for AWS service. Okay. Means service. So this is interact with the EC2. Choose EC2. Next. Here we can add the things. Okay. These are the policies. Which policies we need to attach to our roles. So many policies there. Again, here we just type EKS. EKS service cluster policy estimation. Yep. I think this is the one, right? Choose the EKS cluster policy. Next. Give a name. EKS. Allow instance to call AWS service on your behalf. Create role. Now the role is created. Okay. So the similar way we need to access S3 bucket. Okay. That's another service like EKS. That's for storage our objects. I mean, anything we can store in our Amazon S3. And we need to same create a role for accessing the S3. That's same as service role. So now it's done, I think. So yes. So here to there we need to create our cluster using our details. Okay. So creating cluster EKS using the EKSETL command. So EKSETL. This is command. Okay. Create cluster. Before that, I missed something. I need to attach the policies to this machine. I mean the local machine.
So we need to attach both the policies, right, to the EC2?
No, no, no.
EKS
I only created
three?
one policy.
Oh, okay.
Create one role and I attach the policy to the same role. So here refresh, you can see the role. EKS, you see, and update I am. Now these machines have the access privilege to manage and create Kubernetes cluster. I mean, that service connection authenticate with the EKS service. So go back, cluster. Then the cluster name, okay, name. Here we can choose our design name, okay, like my cluster. I think all are cluster, right? My test. Okay. Then we need to mention the region. Okay. So my region is specified my region. Stockholm is under EU North 1. Okay. So EU hyphen North hyphen 1, right? Then I need to specify the node group. First, I need to specify the node group name actually. Node group name. So here, what is my node group name? For example, my machines or anything like that. Okay. This is the group of my nodes. Okay. Like my node, like this is my name of my node group, my nodes. Then we need to mention the nodes. I mean nodes, node requirement, I mean specification. So that's node type here, node type. So what are the node types available? Anyone know? Here I am choosing T3 small. T3 small type is equal to space. Yeah, T3 small. It's managed. And the last thing is how many count of node or how many node count that we need in our cluster. Here I am choosing 2. So anyone have any doubt? First I am choosing the command line tool, that is ekctl. I am talking with ekctl that I need to create a cluster, and the cluster name is test. Okay. Right. Then where I need to deploy the thing, that is region, and specify the region where we have to deploy the EKS. Then we need to specify node group name. Here my node group name is my node. Then we need to specify the machine specification. So we can choose any machine, okay, T2, large, TT, any machine configuration we can specify here. Here this is, I'm choosing T3 small, this is retail machine, so I choose that one. This is managed machine by AWS, so it's under managed. Then my nodes count, last I need to specify the nodes, what are nodes I need to deploy with the EKS at the
Can you explain manage?
Yeah, manage the.
Yeah, this T3 is managed by AWS. That's why I'm specifying the T3. Okay, that's managed by AWS.
So, what if we take it from there? Like, suppose that we don't put managed, what's gonna happen?
That actually the machines are managed services. When coming to AWS, the instance, spot instance there, managed instances there, so many instance types there. Got it. It's managed by whom? The AWS cloud provider. That's why we are choosing the manager here. Got it.
Oh.
Yeah, everything's fine. Then we can go with the creating the cluster. If everything is done, I mean the roles and policies right, then it will create the cluster. Shall I proceed?
I have a question here.
Hmm.
When kubectl version short client, what is the short in the above command?
No, it's the version actually. Leave the thing. It's the actual version. We can use this thing. I mean, kubectl version. It will show the same version here. It's the client. This is this kubectl for this client actually. Here our machine is as a client.
Okay.
I think I lost the
Yeah,
connection.
for those commands, like to install kubectl and the other one. So can we find that on online, like on Google?
No, I will send the thing.
Okay.
I mean, send the enter code.
So that nodes you mentioned as two, right? Is there minimum or maximum nodes? Is there anything like that? Or just we can give any number?
Yeah, it's good to go with the 2 nodes. That's I explained before, because when we deploy an application, at least we need to keep 2 for high availability.
Is there any numerical limit, upper cap? Let's say, can I keep node as 100, 10, 15?
Sorry.
How many nodes at the most we can create?
That I think we can add more thing. I need to check that. How many? You mean the maximum, right? Yeah, we can add. I think I need to check that. How many? The maximum count.
Also, I think they are scalable, right? After creating nodes, they will scale out automatically, or how it is going?
You mean node scaling or pod scaling?
What are these parts or nodes?
Pod scaling is all things we mentioned in the YAML file inside our cluster.
Oh,
For
okay.
node, we need to add the node as per our command. We need to manually add the node.
Oh, okay.
Yep. Yes, this is, I think, the permission issue. Or I'm changing the role, okay? Because I attach one policy to the existing role. The name is role, and just verify. Yeah, now it's done. You can see it will take some time, around 10 to 15 minutes to creating the cluster. So the thing is using a stack, okay? The stack is a template. So it will create a stack to set up the cluster. And the stack is available in our stack option in AWS. So this is the way installing each step. So yep, first is deploying stack. The stack name is EKCCL test cluster. Now it's waiting for the CloudFormation stack. Yeah, the stack is under the CloudFormation. You know what is CloudFormation? Anyone know? Yes, AWS CloudFormation.
Yeah, that is like the Terraform, but that works only for AWS, right?
Yes, it's like a infrastructure as code that's provided by AWS to automate our deployment. Okay. So for example, in our previous section, we manually create VPC, subnet, all things, right? So we need to automate these things, okay, using some automation tools. So here AWS, the automation tool is called CloudFormation. So we can write up all things. I mean, write all our configuration. For example, we need to create a VPC. So we need to write, we need to create a VPC. The VPC name is this, VPC IP is this, and the subnet is under the VPC. All things we can write, and that thing is called stack, okay, or template. So after write up all things, we need to upload the entire thing to the CloudFormation, and there we can apply the entire code. After applying the code, the CloudFormation will deploy all the things. We didn't go manually to create VPC or subnet or things like that. Similar like Terraform, okay. But we are going with a single IAC tools. That's why the Terraform is most popular. When we are using Terraform, we didn't go to any cloud provider IAC tools like CloudFormation or similar in Azure. There is Azure ARM, Azure templates there. Okay, Azure Resource Manager, under Resource Manager, Azure templates there. That is Azure IAC tool.
So in this command, you have taken T3 small type of machine, but
Yes.
We use a little bit less power machine like T2.
Yes,
also?
yes. This is a base machine with this. The T3 have only one CPU, one core. So you can assume that how much that can process. It's a small machine. That's why they are giving these are free time, because these are very small machines or small processing power machine.
So for our requirement, we need a small machine, right? We don't bother about the...
No issue. Because our requirement is to deploy a sample small application. That's our small requirement. If we are, all things are our requirement, okay? For example, our requirement is to deploy a big size application, that application have a big database or similar like that, then we choose our corresponding machine instead of this T3. For that case, we can choose T3 large or any other machine as per our requirement.
Okay.
Now we can see the things, okay, what happened in our real EKS. Just to go to EKS. There it's automatically create all things under provisioning, I think. Because here you can see it's waiting for the stack. Yeah, it's, you see the test is here shown, right? It's under creating.
So this EKS in one region
Yes.
and EKS in another region is like they can both talk, or is it okay to create like that anytime in the real time scenario it happens?
In real time, we are choosing a region actually. Here my region is EU North 1. Your requirement is, I didn't get you.
No, actually we can create like like same office may have in different regions, right? If the same office, same organization is creating EKS in two regions.
Actually, I didn't get your scenario.
Even I'm also not sure what it is. Just I wanted to know, like we did VPC peering, right?
Yes. That's all the requirement of networking actually. Just that's all the networking part. This is, yeah, this is we creating a Kubernetes cluster. Cluster means nothing, it's we include two machines and we need to manage these two machines, right? Inside the two machine, we create pods, nodes, and containers, all things. So we need to manage these all things using Kubernetes. That's all.
Okay, thank you.
And these are the pure infrastructure. I mean, Kubernetes is infrastructure, and VPC, all things are under network thing. Yeah, all command I will share. Okay. Yes, Andrew, right.
Sir, after creating this cluster, do we have to keep this, or do we have to delete? Like, if we keep and
Yes,
is there any
installable. After your lab, everything is fine. Then we need to deploy and we need to delete this entire thing. Because yeah, and the EKS automatically create so many things like load balancers, so many things it will create under this thing. Okay. So we can delete the cluster. With a single command, we can delete the cluster and the related things that the EKS created.
Okay, fine.
I think your times is up there, right? And our cluster is under creating. I think it will take some more time to finish. If you all are wait, then we can just check the kubectl command tool actually with checking our node count all things. Coming section, we can deploy our application. Okay. Fine. Anyone have any doubt?
Currently, no, sir.
We see the quality of the video, training video is little bit less pixel or something.
No, I think you need to change the pixel in YouTube. I think it's fine because the same pixel we are uploading. You just go to the, that quality section in YouTube and choose the HD, 1080. Can you check?
We will check today and we'll let you know.
Okay, fine. Yeah, Andrew, I'm just creating a single cluster with the 2 node. And for this scenario, we didn't bother about the worker part actually, okay? I mean the etcd, API server, all things are done by the AWS EKS actually. Now first it created the cluster, okay? You can see here. Now we are going to create the node group actually. I think there is times up, right? And 11. I think now you can see our cluster is done. And now it's under creating the node group. Yeah, it's done. You can see. So our EKS tools job is done. So now we need to check with kubectl. Okay. My screen is visible, right?
Yes.
Yeah, we need to check with one more thing to check the cluster. Okay, with the EKSCTL, get cluster. To getting the cluster details, that's all. Okay. Yep. Get cluster. Name of the cluster is test, right? Then we need to mention the region. EU not 1. So you see our cluster test, the version, Kubernetes version is 1.2.5. The latest Kubernetes version is 1.2.8. Okay. And yep, the date, the VPC, subnet, all things created by the AWS. I mean the EKCTL, just to go to the VPC. Because in that template, all things mentioned, okay. When creating Kubernetes, it will create Kubernetes, VPC, and all things, networks. This is the VPC for the Kubernetes.
So it is creating by default a VPC for cluster?
Yes. VPC, so not the VPC, the subnet. 1, 2, 3, 4 subnet.
Yeah, initially when we created EC2, it has a VPC, right? So yes. This is the second one.
Yes.
Okay.
This is for the EKS, that's all.
That means when we create a VPC for networking, we have private and public subnets, everything for our EC2. Then yes. we are creating Kubernetes cluster. It is creating again another VPC. So how these things will interact with each other?
Because both are in AWS, one thing, then we create a service connection, second, and create roles and policies and attach to the our machine, okay, our local machine. I told you because this machine, consider this machine as local machine, okay, like our own laptop or anything like that, okay. So I don't have much privilege. That's why I'm choosing creating a EC2 machine and do the thing. That's all. When comparing to if I am using my own machine, then it's entirely different network and all thing, right?
Yeah.
This mission, consider this mission as this is my mission to manage and creating the Kubernetes cluster. So this mission is a remote mission. Consider this mission as a remote mission. If you have the privilege, I mean, this is my company mission, company laptop. That's why I'm using this EC2 mission because I couldn't authenticate with the AWS account. For your case, the thing you can do is download AWS configure, okay? I mean AWS CLI for your local machine. So you install the AWS CLI, then you need to authenticate with your cloud provider, this AWS account with the secret key and private key, okay? Sorry, access key and secret key. Then you can access your AWS account. Then you can install kubectl, EKCTL and the thing. Then you can directly access with your AWS account and create cluster. Got it?
Okay.
Yeah. So I'm done here. I'm in creating the cluster. So verify our cluster is showing our group. Then we can here we can use the kubectl command, okay? And from here, we can good to go with the kubectl tool because we didn't go with the ekctl for this thing. I mean, after we getting the cluster. So this is the Kubernetes command, okay? kubectl get node. So this is for getting the node count of the existing cluster. So here you see, here there is 2 node count, okay? These are the 2 node. I mean, these are the 2 EC2 machine. One is this and one is this. And we can see that machines in our EC2 instances, okay? So here you see test node 1 and the test node. These are the 2 nodes that we specify when creating ekctl. Got it? And to see the port, kubectl get port, okay? But here we didn't have ports. These are the Kubernetes commands, kubectl get namespace and all things. Okay, we need to dig more into coming section. I think we can wind up today, right? Right?
Yes, sir. Yeah.
Okay.
In Kubernetes, node means EC2.
Yeah. T3 micro.
T3 micro. Okay.
Yeah. T3, not T3 micro, T3 small. That is specified here, right? T3 small. This is my node configuration. Node type is equal to node type space. Which are node we need to include in this cluster. So I am going with the T3 small because this is pre-trained, that's all. I think we can wind up, right?
Yeah.
Now I'm deleting. Yeah, I'm deleting my cluster. Okay. So the command is use kubectl delete cluster, the name of the cluster, then the region. That's all. It's automatically create the entire thing.
Please share the command, sir. Please share the commands before
Yes.
winding.
Yes. Then we can wind up, right? So while I will send the entire code to create a cluster, and you just go through that. After the section, I mean, after getting the nodes and all things, you just delete the thing, okay? And coming section, we will create another cluster and deploy the application. I mean, yeah, I will explain more in the next section. Okay.
So here,
one more request, sir. Please, upload this video as soon as possible.
Yeah, sure.
Then we have the time to practice.
Yes, sure.
Thank you.
Okay. All good, right? For all of you.
Yeah, here, please. For the, I think Andrew was asking the question for the master node.
Yeah, I respond.
I explain to us, please, for the master node, here, can we say our host machine should be the master? Can you give him any explanation?
No. That's a service actually, not a machine for managing that thing. It's all a service that offered by, in this case, it's offered by EKS, and EKS will manage the master part. I mean, it will download, it will set up the master part. We didn't bother about that thing. For some troubleshooting issues, then we need to go to the master part. For example, checking the logs from any master components like etcd or anything. Otherwise, we didn't bother about the master part when using this way. Okay. And the worker part we mentioned 2 node. So we mostly work with the worker part, going to the node and deploying the application to the nodes. That's all thing.
Okay.
Yeah, I have
yeah.
I have 2 questions, please.
Okay.
I want you to help me with this question, very important, about DevOps engineer in the real scenario. What activity I do last week, but I didn't get it right. The activity that a DevOps engineer does every day, the everyday task, if you can give me 1 or 2 tasks, everyday task.
Everyday task means first we go to the mail, check the mails, if any client mails there. I mean, sometimes the clients may face some issues, so they will mail us. And checking, next thing is, if go to mail, if everything is done, then we need to check our, we are going with some service management. So here we are using Jira ticket platform. So if same way, if any customer face any issue or anything, they will create a ticket and they will assign to the concerned person who manage the thing. And yeah, verify that if any ticket assigned to me, if anything they assign to me, then I am the one who need to perform the task. So I will start the process. And yeah, what are the issues they face, then go through that. For example, the issues may like someone didn't access some application or anything. Yeah.
Okay.
Good.
So good. Thank you for that. But the last one also is,
and this is not the thing. These are the 2 first thing. Then go to our CI part. I mean, CI/CD tool. Everything is there. Everything is fine there. Check the build thing, release thing, all things we need to check. Then yeah, we monitoring all things. Okay, we didn't go to the each scenario, because all things we are monitoring in our monitoring tools. So if any error or any issues based on each tools or each scenario, it will trigger in our monitoring tools. So as per the triggering, we just go to the corresponding issue and fix the issue.
Beautiful. Have you met a challenge, an issue where there is a problem of your CI/CD pipeline? And if you have met that, what was the problem? The problem from Jenkins or the problem from the code or something? I just need a story in order to be able to say something when in interview time.
That's we need to check where the issue occur is in the code or in our Jenkins perspective. We need to check. Okay, for example, if in the code we can assume that, for example, we have one code. Okay, the code version 1 code. Okay, sometimes the developers commit another version. Okay, v2, and that v2 we are facing some issues. So we can assume that the code have some issues. So like that, because our CI part couldn't build the package. I mean, build the code. And coming to Jenkins, we can also monitoring the Jenkins. Okay, using the monitoring tool, we can integrate Jenkins. So we didn't go to Jenkins. We can directly monitoring Jenkins with the monitoring tool, and we can see the code. I mean, the build, how many builds are there, how many queues are there, and how many plugins are there. All things we can monitor in monitoring tools.
Okay. No, I just want a scenario where the challenge that a DevOps engineer face. So in this code version you're talking about, is it coming from the Java file area, like developer giving you a code that's supposed to be?
Yeah, we need to feedback the feedback option there. We need to talk with the development team or mail them that actually they will get a mail regarding their issues.
And so we check mail also. Okay, cool.
Yeah.
Thank you. Thank you.
Okay. Yeah, my cluster is done. Okay, I mean it's deleted. You see. So verify that. Go to the case. Yeah, now it's clean. Now cluster. Okay. So we can wind up, right?
Yes, so thank you very much.
Okay. Okay. Okay, then by all, I will share the code, okay, and all are do the same.
Okay, sir.
Okay, bye.
Okay, thank you.
Have a good day.